So this one says find the point on the parabola y squared equals 2x that is closest to the point 1, 4. So I'm finding some point. That means I am finding an ordered pair x, y. And I'm measuring how far it is to the point 1, 4. All right, so how do you measure how far apart things are? There is a distance formula.
What class were we supposed to learn this in again?
We did it.
We weren't in it, so I remember it.
Yeah. The very beginning of college algebra, you did it in geometry.
Yeah, that's why I don't remember it.
Yeah, probably back when we were virtual and
When we were virtual and
hybrid, I guess.
hybrid
You
and
were gone
yeah,
just
and you-
forever.
I got so done wrong that year, and I wasn't even sick as my mother because she worked in this district, you know. Real fun.
Okay, so this is our distance formula that tells us how far apart things are. If I'm looking at this, okay, we know that to maximize or minimize, we have to do a derivative. This derivative is going to be pretty nasty, isn't it? Now we know that inside, if you square something, it's positive, right? And if you add it to another positive number, it's positive. Okay, could we agree that whatever would make this as small as possible would also mean the inside is as small as possible? So what I'm suggesting is to make life easier. Let's minimize d squared instead of d. And the reason that's legal is to get the smallest possible square root, you have the smallest possible number underneath it, right? So since I'm not actually calculating the distance, I think that to be as small as possible. That just means I need the number under my radical to be as small as possible. And if I just focus on that instead of the square root and the chain rule and all of that stuff, the calculus will be easier for us. And we'll get the same result no matter what. So if we think about this. So we're looking at d squared is going to be what we minimize. So x sub 2 minus x sub 1. That says you subtract the x's. We can do it any order, so I'm just going to do x minus 1 squared plus y minus 4 squared. But I don't want to do the derivative of this yet. What do I need to do? Okay, we need it in terms of one variable. So how would I do that?
Divide over something.
Do we have anything else given in our problem that might make it easier?
Oh, maybe, y squared.
Okay, y squared equals 2x. Would this be easier to solve for x or for y? Yeah, so then I could just say 1/2 y squared equals x. So I can replace my x with the 1/2 y squared. Alright, so now what do I need to do? If I want to maximize or minimize, we need to do the derivative. So I'm going to take the derivative of this whole thing. So chain rule. X when it comes down, the inside stays the same. Subtract 1 from the power times derivative of the inside. I'll do the same thing with this one. So x when it comes down, inside stays the same. Subtract 1 from the power times derivative of the inside. Right. Can I distribute my 2 and my y at the same time? I would get y cubed minus 2y plus 2y minus 8. So I get y cubed minus 8 for my derivative. And then what do we do with that? To maximize or minimize, we always set our derivative equal to 0. So y is 2. Okay, so we're finding the point. This is my y, but we know x was 1/2 y squared. So we get 2. So the point on our graph is 2, 2. Questions there? I want you to get out your book. And we are going to do one of these problems. So let's take a look at this. Okay. So this one tells us an oil refinery is located on the north bank.
Oh, this was the one that I was trying to do.
Oh.
Because I thought it was 59,
Well, look at you trying to be an overachiever.
and I was lost.
Of a straight river that is 2 kilometers wide. So what should we do on this?
Draw a river.
Yeah, I'd say we probably want to draw some sort of picture. Start,
I'm so
shouldn't we?
excited.
We need to draw a picture. So I'm not very artistic, so you know mine isn't going to be all that amazing. The river itself is 2 kilometers wide. We have this oil refinery, so, okay, this distance is 2. Alright. Let's see. Then it tells us a pipeline is to be constructed from the refinery to storage tanks located on the south bank of the river, 6 kilometers east of the refinery. Alright, so let's just say, if this is our oil refinery here, and then we're going to have some tanks that are on the opposite side. Oh wait, hold on. Okay. So we've got these tanks we're trying to connect. Let's see. What else have we got? Then it starts talking about the cost of laying the pipe. Alright, so here is our pipe here. What's wrong?
You're a tank.
Me too.
You
See,
actually drew an actual tank?
you guys are overachievers.
I thought it was like tank, oil tanks.
It is. I just drew an actual military tank.
Okay, figure out where we can label some stuff here. What have we got? We have this, okay. So those are 6 kilometers to the east. I feel like my picture is not. Because the 6 kilometers let's call this X for a moment. Could we get a variable for this side? Okay. And can we assume that this would be a right triangle? All right. So then what could we do to solve for y, or to rewrite it? So that would be the square root of x squared plus 4. So the 6, I think that's giving us more of a maximum for our answer. Not really saying that this side is necessarily a 6. We know the cost of laying our pipe is 400,000 kilometers over land and $800,000 per kilometer under the river. And we want to minimize the cost. So we need a cost function. All right, so basically, how are we going to calculate our cost? Take a second. Here's something that's a little bit misleading about our picture. It didn't say that the pipeline went straight under the river to the tanks, did it? So it's going to go under river at some point and then cross land, and then we might actually be traveling over land a little bit to get to the tanks. So what it's saying is my tanks might be over here because it's really expensive to go underwater, right? So we want to make the shortest distance underwater and then travel over land to get to the tanks. Does that make sense? So we know that this total distance is 6. So
If you're trying to go the least amount underwater, why don't you just go straight?
this dashed line is underwater.
Yeah, but why don't you just go straight down if you're trying to do the least?
Well, we may end up, but then we have to look at that adds total distance, so it's like a balancing act. You know, going underwater costs twice as much, but if you have to travel 3 times further on land to do it, then that's going to add to our costs. So we have to figure out, how do we do this to make the least possible cost? So, I do my water is here. So, we have to add in the cost underwater and then the cost across the land. Now, if this total distance is 6 and from here to here is x, then this distance would be 6 minus x. So my cost, my distance across the water costs 800,000, so it'd be 800,000 times the distance across water, which is the square root of x squared plus 4. And then I have to add in my cost on land. Land costs me 400,000. And what's my distance across the land?
X squared, or square root of x squared plus.
That was my water.
Oh, just kidding. Probably
6 minus x. Alright, so if I want to minimize this, what do we have to do?
Derivative.
So a square root is like a 1/2, so 1/2. So then that's x squared plus 4 to the negative 1/2. Derivative of the inside. And then this would be 400,000. Derivative of 6 minus x is negative 1. So 1/2 times 800,000 times 2x gives me 800,000x over the square root of x squared plus 4 minus 400,000. And what do we want this to do?
Where did the 6 go?
Oh, the 6 wasn't really part of my equation. I just got it too close to my picture. Are you talking about this 6 right here?
No, I'm talking about like the 400,000.
Derivative of 6 minus x is just negative 1 because the derivative of 6 is 0.
So you don't, do,
Product rule?
yeah.
You could, but since this doesn't have an x with it, it's
Zero.
not necessary, yeah. So maximum and minimum, we would set our derivative equal to 0. Can I make life a little bit easier and divide by 400,000 on both sides? So then what would you do? Square both, cancel the square root. You get 4x squared equals x squared plus 4. So square root plus and minus. Could x be a negative? No, because it was a disc. So we have to go with the positive. And so then to answer the question, it wanted to know where should the point be located. If I type this in, 2 radical 3 over 3. Then that will give me a decimal, kind of approximate it. So that is my x, so keep in mind these tanks, we'd have to write some sort of sentence explaining what that meant. It's like 1.15, so that's how far over we would have to go. So they would have to be set, I mean, you could say the total of 6 minus x, so 6 minus the 1.15, so it'd be like 4.85 miles east of the refinery. Would make sense. So different ways you could write that to answer. So, the hard part on these is the setup. The calculus is just a derivative, find your maximum or minimum. Friday, I gave you guys 3 problems. I am going to give you 2 more, and then we're turning this in tomorrow. So,
So then I can still ask you.
I want you to add 5 and 16.